Hi guys, I'm going to demonstrate to you the experiment 3, which is magnetic circuit experiment by using MATLAB software. So in this experiment, we are going to do some calculation on the parameters of the magnetic circuit. For example, we are going to calculate the magnetic force, the maximum flux density, and also the permeability of the material. Okay, so now, first of all, you have to open your MATLAB software. So once you open your MATLAB software, here is the line windows that will be appeared. So I'm using MATLAB R 2017A version, so the layout might be a little bit different if you're using other version of MATLAB. Okay, so now, this is where we want to write our coding here, which is common window. Okay, this is the simplest way that I will show to you, okay, by using common window to do the calculation and to plot the curve. Okay, the other ways that we can do is by using this script. Okay, you can do your coding, write your coding inside this script here. Okay, but for this time, I just want to explain to you how to use this common window to get a value for your equation, okay, calculation. Alright, so first of all, we have to see the coding that has been given inside your lab manual. Okay, you can see the value has been given, certain values has been given. Okay, we go to the first one here. Okay, you can see the first line here is actually the comment. Okay, it is started by this percent symbol, and this is just a comment. It is not compulsory, but it is very recommended to write the comment so that you will know what calculation you are going to use and so on. Okay, so here are the list of values here already given to you. So once you enter all of these values here, you can see in your workspace, okay, it has been inserted inside here. Okay, so for V1 and I1, it's just voltage and also current at the primary side. N1 and N2 is the number of windings at the primary and secondary side. L is just the length. Okay, A is the cross-sectional area. F is the supply frequency, and mu is the magnetic constant. Okay, in your laboratory manual, can you refer to your table 3.1? Okay, in your table 3.1, you have to insert the value for primary current I1. So it is actually given here, I1. Okay, you can just type back I1 so that you can see the values here clearly. Okay, so you just write down all of this value inside the primary current one, I1 column. Okay, so V1 and V2 is already given inside the table 3.1. Okay, so now we go to the next line. Okay, refer to your coding. Okay, so the first one, we want to calculate the turn ratio and V2. Okay, so to calculate the turn ratio and V2, here are the equation. A is equal to N1 over N2 and V2 is equal to V1 over A. Okay, so how you want to get the values here, the results here, you just type the small letter A. So you will get the value here 2. Okay, and then V2, you will get the value for V2. Okay, it's just the same like has been inserted inside your table 3.1. It's already given to you, V2. Okay, so now we want to calculate HM, BM, and mu R. Okay, as required inside the table 3.1 over there. Okay, so inside the coding here, it has been given to you the equation to calculate the HM, BM, and mu R. It's just very simple. Just write the coding here. Okay, this is the coding here, the equation. This is the comment, and this one is the equation, and you will directly get the value for HM. So the value for this one here is actually 1 times 10 to the power of 5 times each of the value here. Okay, so for example, for this one 0.0283, So you have to times with this one here to get the actual value of the HM. Okay, you can also do some calculation inside here. For example, this one, and then times with this value here. Just copy and paste, and then this is actually the value for HM. Okay, this is the value that you have to write down inside the table 3.1. Okay, for the next calculation, we are going to calculate the maximum magnetic flux density, Bm. Okay, you repeat the same process, just write down the equation here. Just write down the equation, and directly it will give to you the value for Bm. So this is the equation for Bm. Okay, and this one is the results. So the results here you have to insert inside the table 3.1. Actually, the equation that we are using here is already given inside your manual. So for this one, the Bm here, you can refer to your manual. It is actually referred to equation 3.4. Okay, for Hm, this one here, this equation is referred to equation 3.2. Okay. For the next calculation, which is the last one, we are going to calculate the relative permeability of the material, or μr. Okay, just insert the equation in the command here. Okay, so this is the equation. Okay, and then here are the results that you get. Okay, this equation, refer to your notes. Okay, it is actually equal to equation 3.1 in your manual. Okay, so this is the value that you have to insert inside the last column in the table 3.1, which is equal to μr. Okay, so now you already obtained all the values inside the table 3.1. Okay, not to forget to insert the value for Hm. Okay, the one we have to consider the value, this one here, 1 times 10 to the power of 5 for each of this value here. Okay, so now you are ready to plot the graph. Okay, actually you can manually plot the graph. Okay, because you already obtained all the results. Okay, so inside your report you have to manually draw the graph. Okay, so now I'm going to demonstrate to you how we want to create the graph by using this MATLAB. Okay, it's very simple. You just have to use the plot function. Okay, so let's see here. So I just have to insert this plot function here, and it will automatically open the graph. Okay, so you can see here, these are the graph. This is the graph that you will get. Okay, but there's no label here, x-axis and y-axis, and the title also you not include yet. So you just have to write down the x label, y label, and also the title. Okay, so that is easier for you to see the details about the graph. You just include inside the command here, and then directly it will appear on the graph. Okay, so x-axis is referred to the h value, and the y-axis is referred to the b. Okay, so this is the title here. Okay, and then in order for you guys to read this table easily, okay, it's better you guys to insert the grid. Okay, so you have to turn on the grid, just write grid on, and automatically your graph will have the grid here. So it's easier for you to read the value from the graph. Okay, from the graph here you can see that it started with a non-linear here, and then after that it will become linear, and after that this one it increased just a little bit, which means this one the incrementation is not very large. Okay, it is this is the state where the saturation occur. Okay, so it's very important for you guys to know the condition here, because later on you have to include the relative probability of the core for the linear portion, and also when the core started to reach the saturation. Okay, after we obtain the next curve, we can get the value. Okay, after this. Alright, so let's draw the next graph. Okay, so the next graph, you're going to plot the mu r curve versus Hn. Okay, you just repeat the same process, write down the plot function, write down the x label, y label, the title, and turn on the grid. Okay, so directly it will appear the latest curve that you have plotted. Okay, so this one is the mu r versus Hn curve. Okay, at the bottom here, this is the x-axis, refer to h, and the y-axis here, refer to mu r. Okay, so this is where you want to read the mu r when the time the graph become linear and saturate. Okay, you have to find the value for your mu r. Insert your result inside your reports.